independent and dependent event, or we call it as the probability of a multiple event. When we say independent event, that means one event is not affecting the other event that you have in the problem. Whatever you do on that event, it will not change the probability. Okay. And we find the probability of an independent event by multiplying the probability of the first event times the probability of your second event. That's what we have, or the formula that we use in finding the probability of our independent event. This is the formula for independent event, which is probability of an event A, for example, that is your first event, and your second event is in the symbol of B. So you're just going to multiply probability of A, or the first event, times the probability of the second event. Or we use this symbol if you have a discussion already in Venn diagram or a set and subset. When you are in grade 7, this one is a symbol for intersection. Okay, for a set and subset. When you have already discussed that when you are in grade 7. So you're just going to find the product of the two events that is being presented in the situation that we have. For example, we have this problem. A coin is tossed and a six-sided die is rolled. Find the probability of landing on the head side of the coin and rolling a 3 on the side of your die. So we have two situations or two events in the problem, which is the first one is tossing a coin, and the second event that we have is rolling a die, a six-sided die. Since it's a two event, it's an independent event. So the formula that we're going to use, probability of event A and B is equal to the probability of your first event times the probability of our second event. So for us to be able to find the probability of our independent event, we need to know first what is the probability of your first event. So go back to your first event, which is tossing of coin. Since that is your first event, what is the probability of getting a coin once you toss the coin? What is the probability of getting a head in the event that we have once we toss the coin? What is the probability for that event? 50%. We have 50% for our first event, which is equal to 1/2. Let's use the fraction form. Or 50%, if you want to use the percentage, it's fine, as long as you can solve the independent probability. So that is our first event, which is equal to 1/2, multiplied by the second event that we have, which is rolling a die. Okay. So once we roll our die, what is the probability that we will get a 3 on a die? What is the probability once we roll the six-sided die and we will get a 3 number for that die? One over 6. So we have 1 over 6 for our second event. That's the probability of the second event that we have in rolling the die. So 1/2 times 1/6, the probability that we will get is equal to 1 over 12. So that is the probability of our independent event, which is rolling a die and tossing a coin. So, ganyan lang ang gagawin. You're just going to multiply the probability of the two events that you have in the problem. Okay? But if the fraction can be still simplified, you may simplify. Kung percentage ang gagamitin for both of your event, kung percentage ang ginamit for your first event, percentage din ang gamitin for your second event. Para same, common, ang variables that you use for your formula when it comes to solving for your independent event. Okay? Okay, let's have another example. Can I clear the screen with this one?
Yes.
So for example, we have this problem. A card is chosen at random from a deck of 52 cards. It is then replaced and a second card is chosen. What is the probability of choosing a jack and an 8? So it's an independent. We need to find the probability of getting a jack and 8. So since we're solving for the probability of getting a jack and 8 using the formula for the independent event, kapag sa problem indicated and, that means it's independent. Kapag or ang nakalagay, that's dependent. That's how you can identify what formula you're going to use. Kapag and ang hinahanap or and ang naka-identify sa problem, that's independent. Kapag or ang nakalagay sa problem, that means it's a dependent event. So probability of getting a jack and an 8. Since we have 52 cards, and how many jack it is, ilang jack ang meron ng 52 cards or the deck of cards that we have? Ilan ang jack sa deck of cards?
4.
4. So we have 4 jack out of 52 cards. Ilan ang 8 sa deck of cards?
4.
4 din. So 4 over 52. So 4 over 52 times 4 over 52 is equal to 4 times 4 is 16. 52 times 52 is equal to
2,704.
1,700.
2,000 po.
2,704. Tama? Okay, so we have 16 over 2,704. Can we still simplify this probability or this fraction? Pwede pa ba i-simplify? Si 16 over 2,700, 1 over 15. $169. So that is our probability of getting a jack and an 8 in the deck of cards that we have. Okay, so that's how simple you're going to find the independent probability. For example, we have this one. A jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. A marble is chosen at random from the jar. After replacing it, a second marble is chosen. What is the probability of choosing a green and a yellow marble? Yeah, what will be the probability that you will get a green and a yellow marble? Can give me the answer for the probability of getting a green and a yellow marble.
5/16 and 6/16.
5 over 16 times 6 over 16, which is equal to
30/256.
30 over 256. So that is the probability that we will get a color green and a color yellow marble. Okay, now with the independent variable or independent event.
Yes.
Okay, so let's proceed with the dependent. How to find the probability of our dependent event. So dependent event, so kung si independent is not affecting the result of the other event, when it comes to your dependent event, the result or the probability of the first event will affect the probability of the second effect, the second event. Usually, you will see the words without replacing in the word problems for you to identify that that problem is a dependent event. Kapag merong without replacing sa word problem, that means you need to use the formula for the dependent event. It's the same. You're going to multiply the event of the first and the probability of the second event. The same with your independent, wherein you get the product of the probability of the first event multiply to the probability of the second event. Just this is the formula for the dependent event. As you can see, the same finding the product, but this one is being changed in the formula for your independent. This means that this probability or event is being changed based on the probability of your first event. Okay? So, nagbago yung probability when it comes to to the dependent variable or dependent event. Let's have an example when it comes to dependent. So let's say we have this problem. A jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. A marble is chosen at a random from a jar. A second marble is chosen without replacing the first one. What is the probability of choosing a green and a yellow marble? So getting a green and a yellow without replacing the first one that you have chosen. So if you're going to imagine or visualize the problem, sa jar, merong mga marbles with a different colors. Your first marble that you get, you're not going to return it in the jar. That's why it's without replacing. That's the meaning of that. Or without getting back the marble that you have get already for your first try. So probability of getting a green and yellow. So probability of the first event multiplied to the probability of the second event according to the first event that we have. So we need to identify the probability of the first event. So we have how many green? We have 5 green with a total number of marbles which is equal to 16. That's the total number of marbles that we have in the jar. So from the first event, we get 1 marble which is colored green. For our second event, the number of marbles will be deducted by 1. So dati, in the first event, 16 yung marbles. Your second event, the number of marbles now will become 15. So your yellow, the number of yellow marble is 6. So that is the probability of our second event. Bakit nag-decrease ng 1? Because the event that you did first is affecting the probability of the second event. That's why it becomes 15. So getting the product, for the first event that we have, which is 5 over 16, and the probability of the second event, which is 6 over 15, we have the probability of our dependent, which is equal to 30 over 16 times 15 is equals to what?
40.
40. 40
To 40.
to 40. So that is the probability that we will get a green and a yellow. Okay? That is for the dependent. Nagbabago ang number of total chances of your probability. Yun lang the only thing that changes in your dependent. Yung total number of outcomes is the only changing. Since this one means that the total number of outcomes in the formula for probability of simple event. The denominator stands for the total number of outcomes. So yan lang ang nababago when it comes to the dependent. You decrease depending on the number of chances that you created in your first event. So let's have another example for the dependent event. So for example, we have this problem. An aquarium contains 6 male goldfish and 4 female goldfish. You randomly select a fish from the tongue, do not replace it, and then randomly select a second fish. What is the probability that both fish are male? So what is the probability daw that you will get both male for your aquarium? So finding the probability of a male and a male. So probability of the first event multiplied to the probability of our second event. So probability of the first event, kung the original number of goldfish in the aquarium is 10, so 10 pa rin siya from our in the first event. And the number of male in the aquarium is 6. So that is the probability of our first event, 6 over 10, multiplied to the second event in getting a male again in the aquarium. So if the original number of goldfish is 10, we will deduct 1 since kumuha na tayo ng isang goldfish. So 9 na lang yung fish sa aquarium. So kung yung una, male na din yung kinuha natin, that means the number of male in the aquarium now is 5. We deduct also from the original number of male in the aquarium. Since yung unang kinuha natin is male na. So nabawasan na yung male na fish sa aquarium. So we only have 5 over 9. Multiply 6 over 6 is equal to 30. 10 over 9 is equal to 90. Lowest term, the fraction that we have. So we have 1 over 6 as the probability of getting a male and a male goldfish in the aquarium. So that's how we solve this problem for the dependent event that we have. Okay na? Done. Writing the one that we have on the screen. So let's proceed with another example. So for example, a random sample of parts coming off a machine is done by an inspector. He found that 5 out of 100 parts are bad on average. If he were to do a new sample, what is the probability that he fix a bad part and then fix another bad part if he doesn't replace the first? So according to the problem, we have the parts from the machine. And meron 5 out of 100 part is being defected. So what is the probability that we will get a defected parts and then get another defected parts? Okay. So probability of getting a bad or a defective parts of the machine without replacing the parts that you have already get. So the probability that we have for the first event, what is the probability for the first event? In the problem that we have on the screen. What's the probability of our first event of getting a bad parts from the machine?
5 over 100.
5 over 100. So that is the first probability that we will going to have in our event. Since that is the only given stated in the problem, 5 out of 100 parts. Multiplied to the second probability or the probability of our second event. What is the probability of the second event? That you will get a bad or a defective parts from the machine. Kung 5 out of 100, yung una, ilan na ngayon ang probability for your second event? Oh, what's the probability of our second event? If the first one is 5 over 100, ano na ang probability ni second event? To get, or that you will get another bad or defective parts of the machine. Ano na ang second probability natin?
The denominator is 99. That's it. I don't know the number.
The denominator is 99. So according to Gabi,
Yes, sir.
99 daw si denominator, which is correct. What about the numerator?
Walang numerator. That's it. The end.
Walang
Okay.
numerator? Paano
Star.
naging fraction yun na walang
Or no,
numerator?
yeah, next parts, next machine. Done by next machine na lang.
Next machine na lang? Oh, ilan kaya ang numerator ni 99?
3?
3. Bakit 3?
Because it says if he were to do a new sample, what is the probability that he picks a bad part and then picks another bad part? So 5 minus 2 is 3.
5 minus 2 is?
I don't know what
Three.
I don't know what I'm saying. I don't know what I'm saying.
5 minus 3 is, 5 minus 2 is 3, which is correct naman. Tama naman yung 5 minus 2 is 3, which is
5 minus 2 is
correct.
3.
Yeah, that's
But-
correct. 5 minus 2 is 3. But that is not the number of,
But that is not correct.
Okay,
but
name
that is
teacher.
not our numerator for
Yeah.
the 99.
1?
Oh, 1 daw kay Charles. Bakit 1, Charles?
If 2 isn't correct, 1 might be correct. I don't know.
So if, if 1 is incorrect, 1 is correct. Parang pati ako nahilo doon. So if 1 is incorrect, 1 is correct. The same of what you did with the total number of parts, you deduct 1. You're also going to deduct 1 to your number of the defective or the bad parts of the machine. So you have 4. Okay? That is 4. Marinay. The meaning of this one, he picks a bad part. That's 1. That is your first event, 5 over 100. You get another 1. That's your second event. So you deduct only 1. Okay? Tama sana yung interpretation of job, but you deduct it 2. Dalawang beses ka lang kumuha. Yung una at yung pangalawa. So you only deducted 1 from the original number of your defective or bad parts of the machine. So we have 5 times 4, which is equal to 9. 100 times 99 is equal to 900, 9,900. Or we have 1 over 110 So that is the probability that we will get a bad and a bad part. 1 over 1,100. We always deduct 1. Isa lang lagi ha. Always decrease by 1. Hindi pwedeng tumaas ng dalawa. Depending kung ilang beses kakuha. More on, we always subtract it by 1 only. when it comes to the dependent event. So let's try to identify how can we identify or determine if the problem is indicating an event, an independent, or an independent event. So to determine if an event are independent, just substitute what you know and check to see if left side equals to the right side. We have three ways to check in determining if an event is independent. For example, this one. For example, let the event M equals to taking a math class, and let S taking a science class. Then M and S is equal to taking a math class and a science class. Suppose we have the probability for a class is taking math, which is 0.6, and the probability is taking science class, which is 0.5. And a total probability of taking a class of math and science, which is 0 and 3. We need to identify if M, or the event M, and S are independent. So let's substitute. Kapag nag-equal, that means the problem that we have is an independent event. Given that we have the probability for M and S, which is equal to 0.3, equals to the probability of M, which is 0.6, times the probability of 0.5. So 0.3 equals 0.6 times 0.5 is equal to what? Equals to, what is 0.6 times 0.5?
0.3.
0.3. So this problem, or the probability that is being presented on the screen, is an example of an independent event. Okay, that's the first way for you to determine if a problem or the given is an independent event, by substituting from the formula of an independent event. The other way that you can use to identify if the given problem is an independent
No.
So as you can see here, the two probability is not equal. So it means the given problem that we have, just in particular college class, there are 60% of the student are female, 50% of the student in a class has long hair, 45% of the student are female and have long hair. Of the female students, 75% have long hair. Let F be the event that the student is female. Let L be the event that the student has long hair. One student is picked randomly, or the events of being female and having long hair is independent. So using substitution, 45% for both female and having a long hair. Okay. Based from the problem that we have 45 students that are female and have a long hair. And the percentage of a female in a college class is 60%. So 60% times the percentage of a long hair is equal to 50%. So 45% equals to 60 times 50%, which is equal to 60 times 50% is equal to 0.30. So that means this problem is not an independent event. So if it's not equal, it's not independent, that means this problem is an example of a dependent event. So kung hindi siya independent, since hindi nag-equal, so the given problem that we have is a dependent event, wherein the first event is affecting the probability of our second event.